Today we're on page 10 of the Chapter 11 Discovery Labs on solubility rules and double replacement reactions. Today we're going to be learning how to write the double replacement reaction for the precipitates that were formed, as well as what we call the net ionic equation for each of those reactions. The example I have on top of the paper is a reaction that made a white precipitate. First of all, notice that in this double replacement reaction, we made a solid, and one of the other product was aqueous. So you take two aqueous solutions that have no solids in them because they're soluble, and then when they combine, they switch spots. So the copper went with the chloride and the barium went with the sulfate. That's a double replacement. So now the copper and the chloride are here, and the barium and the sulfate are here. Now, if you look at your solubility rules, you should understand why each of these is soluble or insoluble. So the first one, CuSO4, is soluble because it's a sulfate. Sulfates are soluble except for Cabasser-Pub-Hog2, and copper is not part of that. The next one is a chloride, so Brickles trickle except for the happy tickle, and barium is not part of the happy tickle, so this is soluble. Then you look on the right side and you see cupric chloride. And again, this is a Brickles trickle except for the happy tickle, and this is not a happy tickle, so it's soluble. And then you have a sulfate, and that's part of Cabasser-Pub-Hog2. So sulfates are soluble except for Cabasser-Pub-Hog2, and you see that barium is part of Cabasser-Pub-Hog2. So therefore, this is insoluble. So every double replacement where you have a plus minus and a plus minus, you're always going to have one precipitate formed in this lab. Okay, so that's what we call the complete molecular equation. Now what we have is called the net ionic equation. It's the equation that shows just what's the most important thing happening. So the most important thing that's happening is we're making barium sulfate. And from where do we make barium sulfate? We make it from barium ion and sulfate ion. So that's easy. You just take the precipitate that you make and then figure out what ions from which it came, and then write them down. So what we're going to do in this rough copy of the lab is we're going to only do the reactions for Na2CO3 from the lab. Okay, there were lots of reactions that made precipitates, but since carbonates are insoluble because they're part of Skocropo, unless with a good guy, such as sodium, we're going to do just the reactions that involved sodium carbonate. Okay, so here they are listed. First there was AgNO3, then CuCl2, and the next page has a bunch of other ones. So let's just start. I'm going to do this one as an example for you. So we took AgNO3. I'm going to write that one down. AgNO3. And of course that was soluble because you know NOCHO-CLO is soluble. So that was AQ plus the Na2CO3. That's soluble as well, even though it's Skocropo, it's with a group 1. And now you're going to do the double replacement. So remember that the charge of silver is plus, nitrate is -1, sodium is +1, carbonate is -2. So you're going to do a double replacement, meaning the silver is now going to go with the carbonate, and the sodium is now going to go with the nitrate. So when you want to put the silver together with the carbonate, you have to figure out what formula it will make. Since silver is +1, and carbonate is -2, you're going to need to have two silvers in that formula. Then we're going to have the other product is the Na with the NO3. So here's Na, here's NO3. Their charges are +1 and -1, so they're fine. And then we're going to balance the equation with coefficients. So here you have two silvers, and one silver, and here you have two silvers. So you're going to need to have two silvers here, so you're going to put a 2 in front. So this is going to be a 2. Now by doing that, you changed nitrate. So you see that you have two nitrates on the left, and we have only one nitrate on the right. So we need to put a 2 right there. And then by doing that, we made two sodiums. So since there are two sodiums on the right, we have to have 2 on the left, which we already have. So you could write the 1, or you could just leave it out. It's understood if you don't write it. I'll write it just so we know we did it. And then lastly, that affected carbonate. So we're going to look at carbonate. There's one carbonate on the left, and there's only one carbonate on the right. So we are going to have that Oops, we're going to have that 1 here as well. And there's my balancing. Okay, the next thing we have to do is figure out which one is the solid and which one is the not solid, the aqueous, on the right side. So we have two choices. So here you have carbonate, that's part of Skocropo. That's usually insoluble, and since silver is not part of the good guys, you know that that is indeed the precipitate. So this is going to be the solid. Let's check why this is not the solid, and that's because you can tell that this has group 1, which is good guys, so for sure it's going to dissolve, and nitrate is also part of notroclo, so that's going to dissolve. So then this is going to be aqueous, AQ. And then don't forget to fill in the color that this was from your lab data. So this is what we call the entire double replacement reaction. It's balanced. We included the states of matter. And now what we're going to do is the net ionic equation, again balanced and again including the states of matter. The best way to do this is start off by writing the product that was the precipitate. So Ag2CO3, that's the solid. So from where did we get that? We got that from silver ion, which was AQ, and the carbonate ion, which was also AQ. And don't forget that this has to be balanced. So you need 2 silvers because 2 silvers are going to be needed for the product. And you can see it from the top equation. There are 2 silvers here, so you put 2 silvers here. There's only 1 carbonate here, so there's only 1 carbonate here. And just a little hint, let's suppose this came out to be 4, 2, 2. You could reduce that. So 4, 2, 2 would be the same as 2, 1, 1. So you always want these to be in the lowest possible terms in the net. So I'll write that. Okay, I did the first one for you, and now you should be able to do all the rest of the rough copy for tomorrow.